Okay, I wanted to perform another line reflection with a line that is not vertical or horizontal. So a little more practice on this. What we're going to do is we're going to take the point A, which is at negative 1, 6, and we're going to reflect over the line y equals x, point A, to produce A prime. Okay, so let's go ahead and we're going to plot negative 1, 6, that's A. You should plot the line y equals x, start at the origin, go up 1, right 1. Okay, that's the line, y equals x, use a straight edge. Okay, I'm not, but I can't on this. All right, so y equals x is that line. Sorry. Okay, and what we're doing is, again, this is, trust me on this, you want to plot the path first. The path A is going to travel. Now, basically what we're saying is, this is our perpendicular bisector of A to A prime, right? So if you know the perpendicular bisector, or the mirror, what you have to do is first get its slope. So its slope is up 1, right 1. Okay? A perpendicular line would have to have a slope that is down 1, right 1. So that's how we're going to travel. A's path is going to go this way to reach A prime. We just don't know how far. Okay? So we'll just go ahead and lightly dotted line to show that it's really not true. You know, there. Somewhere along this path is where A prime will land. Okay? Now let's count the distance. There's one diagonal, 2, 3.5. There's your half, and then 1, 2, 3. A prime is going to land right there. Okay? So A prime hit the location 6, negative 1. And going back to the rule that I taught you, did X and Y just switch? Yes, that's specifically for reflecting over Y equals X. Okay? So that's how you should do this. Now I'm going to do one that is above the difficulty level that we teach in the high school, just so you could see this process again. All right? So we're going to graph B, which is negative 4, 3, and we're actually going to reflect over a crazy line. We'd never do this really in class. We're going to reflect over, what did I write down? It was, looks like we're going to reflect over the line y equals 2x minus 4. Now, we'd never really do that in this course, but I really want to hit home the concept of perpendicular bisector, B to B prime. So the mirror is going to be this line here. Okay, so this can be done. This is your mirror. And again, if you don't know how I'm graphing that, please see your teacher. Stay after school. That's something that we need by now, but that's just something you need to work on if you don't know how to do this. Okay, so this is the line y equals 2x minus 4. All right, now let's go grab 4, 3. Negative 4, 3, I'm sorry. So this is B. B prime is going to be somewhere over here. Think fold over this. Okay, it's going to be over there. Now, if this is your mirror, right, then B to B prime must be perpendicular to it. Well, so what's the mirror's slope? All right, the slope of the mirror is 2 over 1. Okay. Now, the perpendicular line, so B to B prime, has to have a slope that is negative 1/2. So basically what we're going to do is, again, we're going to sketch the path B has to follow to find B prime. B has to follow a down 1, right 2 path. Okay? So there it is. This is B prime's path, so that it's perpendicular. Remember, that's one of the first things. So B prime somewhere is on here, on this path. This is the B prime path. Now, how far away is B from the line? Now, we're going to get lucky here. If we follow this, it's 3 of those over 2 down 1s. Okay, so let's do that 3 times. Okay, over 2 down 1, that's where B prime is going to land. 3 of those away. So B prime would land at looks like 8, -3. So yeah, so that's reflecting over a line that has a slope other than undefined or 0 or 1 or -1. So this is a really strange situation. We probably won't face this, but it's important that we understand it, and we'll be a lot better off. Okay. Now, there's another problem that we would potentially face that connects us to Chapter 1. Okay. And that is if I give you the pre-image and the image, would you be able to find the line of reflection? Okay, so the question will be is to find the equation of the line that we reflected over or through. So let me get you those points, and we'll show you how that process will begin. Okay, so the points that I designed here, if let's say A is 2, -3, and A prime is 6, 5. Okay, basically this is a problem from the last chapter of Geometry Basics. What we gave you was we gave you 2 points, and we said write the equation of the line that is the perpendicular bisector. Well, that's essentially the concept of a line reflection. The line that we reflect over is the perpendicular bisector. Or through. Some people use through. So the line that we reflect over or through is the perpendicular bisector of A prime, the segment. So let's go graph those. Okay, so there's A and A prime. So we're trying to find the perpendicular bisector. What I typically do is calculate the slope. Okay, so we got a rise over the run. So for A to A prime, we got a slope that is up 8/4. It's positive. If you want, we can reduce it to 2/1. And so a perpendicular line to A prime is going to have a slope of -1/2. Now, what point do we go through? The point we got to go through is the midpoint of A prime. Okay, so that midpoint, again, I use the graph if I can, going halfway between. So I'll go, instead of going 4, I'll go 2, which is half. Instead of going up and down 8, 1, 2, 3, 4, it's right there. Those two meet right there. So that point is on the perpendicular bisector because it's the midpoint of A prime. That's 4, 1. Okay, so 4, 1 is the midpoint. All right, and so what we can do is go back to our y minus y1 and x minus x1. Okay, that's x1, y1. All right, so we get y minus 1 equals -1/2 and x minus 4. Now, of course, if you want the y-intercept, you could do it this way. Looks like it's going to be +3. If you like to graph it that way, that's good too. So this is how you would do it. Basically, it's an application of finding the perpendicular bisector between 2 points. Okay, so last things I want to include on this video are critical ideas of properties. Okay, So we're going to go back and look at Geometry Sketchpad in a minute and look at properties of especially orientation, because that's the main one for line reflections. Okay, so we went back over to Geometry Sketchpad and got an example of a line reflection. So here's the line reflected over. Okay, some of the properties we got to go through. First is orientation. When I look at orientation, the easiest way to describe that is that's the arrangement of the vertices. So if we're talking about triangle ABC and we talk about its orientation, then we have to talk about the corresponding triangle A prime, B prime, C prime. Orientation. Here's what I do. I start at A, I move to B, and then pass C and back around. If you start at A and move towards B, back to C, and so forth, it either is clockwise or counterclockwise. This is counterclockwise. So that's what I call its orientation. Now, so we're going to say the orientation of ABC, that's going to be counterclockwise. If you go over to triangle A prime, B prime, C prime, start at A prime, move over. So for triangle A prime, B prime, C prime, it's actually following the clock, so it is clockwise. So the big thing with all line reflections is the orientation will change. Okay? So what we say in this course is orientation is not preserved. Okay, so when we go through our different list of transformations, one of the key concepts we'll look at, one of the key properties will be orientation. When orientation is not preserved, okay, and that's something else that we'll talk about. So when orientation is not preserved, and we talked about preserved in class, but I'll clarify that too. When orientation is not preserved, there must have been an odd number of line reflections. Now, line reflection is the only transformation that we study that does not preserve orientation. Okay, so when I say odd number, it gets a little tricky. We'll go over this very soon. But if you line reflect once, right? Say we go that way. Well, when you line reflect back, you'll notice that the orientation goes back. You know, so it's every other one where the orientation is going to be not preserved. So this is more discussion, but that's the one we're going to focus on the most. Other properties that we use, such as slopes. The slope of this line, AC, is not necessarily going to be the same as the slope of A prime, C prime. So slopes don't have to be reserved. Okay, so might not be preserved after a line reflection. Okay, so there's a couple different things we look at with line reflections, with orientation, slopes, things like that. Those are your big ones. Look for those, and that's how we're gonna utilize that information later. Okay, thanks for tuning in, and we'll get the next one up for point reflections.